Start with education and curiosity. Now, everybody. Hello.
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 There's a few of you here. Hello!
Hello.
Hello, we're shouting out for tomorrow evening. Yes, I know. Well, in the first one, we're playing a series of on this lovely representation of something called, they don't know what it's called. We've got letters, names, and numbers. We call it
Periodic table.
It is, well done children and adults, the periodic table. The periodic table was invented by Dmitri Mendeleev in Russia in 1867 and represents all the elements we know. Now what are elements? Of course, elements are the most simplest materials we can build things from. So whether it's a solid, liquid or gas, it is an element, or combination of elements. I know if you haven't heard of elements before children, you've probably heard of iron is a very strong element. Oxygen is something we should breathe, and dare I say it, you adults have come across the elements silver, gold, and platinum. Now, children, adults and children. Some of the experiments I'm going to be doing are really easy. Some are a bit difficult. Some are a bit complex, and some are downright dangerous. So if I ask you children to take your hands off the table, I do mean take your hands off the table. Do not put your hands on the table. Do not put your elbows on the table, and do not little feet on the table. If you follow my advice, we'll have a fun and safe chemistry bar demonstration. So, I've got a little problem. Some of you may be there's a member football match on tomorrow, yes? Oh, well, I thought I might prepare myself in earnest by having a little drink of water. Problem is, I don't know which test tube I put the water in. Now, it could be this one, but this could be the one my friend Amanda brought up. And she said, Carlos, do not drink that one, it's not a good idea. And then again, it could be this one. And this one is my friend Guy brought up. And he said, Carlos, I put something in here 2 weeks ago, I haven't got 2 of these now, so don't drink that one. This one, I have no idea what's in, but it looks cloudy, like, should I drink that? I don't know. And this one, I friend Harley brought up, she said, so it's very dangerous in there, do not drink that. Or was this the one that Harley brought up? I don't know. Should I drink this, children? Thank you. Should I drink this one? Thank you. Never drink something you don't know what it is, children. It could do you harm. So to find out which is which, I'm going to teach you the pH scale. And the pH scale is all about things called alkalis and acids. Acids and alkalis are very reactive chemicals, and acids take the value 1 to 6, where 1 is a super strong acid, 6 is a very weak acid, and alkalis take the value 8 to 14. Where 8 is a very weak alkali, and 14 is a super strong alkali. If you take an equal strength acid to an equal strength alkali and mix them together, they neutralise each other, and we get number 7. And water is generally 7. So, to find out which is water, I'm going to add something. It's called universal indicator. And also, if you want to make an indicator at home, what you can do is take some red cabbage, dice it up really finely, put it in water, boil it for 20 minutes, and then seal off the cabbage pieces, and the liquid you'll have left will act like my indicator. But indicators scan stain. You ever had beetroot on your clothes and stuff? Yeah? It stains a lot, so indicators can stain a bit. So we want to use some gloves. And the hardest thing about this demonstration is we put on the gloves. We could be here for about 10 minutes or so. And you know when you're wearing one the gloves, yes? They're the same, probably 2 fingers in the same finger. Is that what that is? That's it. If I get the gloves on, put me a round of applause. Yeah. I appreciate it. I'll put some goggles on for good measure. And I'm going to get you, young lady. What's your name?
Effie.
Effie. Hello, Effie. The girl who is very silent. I don't need to be silent, I want you to point to a test tube. So point to a test tube, Effie. She chose them, she thinks it. Point to it, then put your finger towards it. That one? Thank you, Effie. Give Effie a round of applause. Thank you. Now, hands up for acid. And thank you, sir. Hands down. Hands up for alkali. Hands down. Hands up for neutral. Okay, let's find out what it is. So what we're going to do, we're going to take an observation. Observation, not what we know, is what we see, hear or feel. So what colour do you see now? Put them all in. Let's be certain. I'm going to hold this up. Over there. So, what colour is that? Green? 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 All of it green? Okay. Is green on them? Let me take one look myself. Yeah, this could be our water. So, well, you're very good if you put that at me, so well done, but we'll have to find out by choosing another test tube. So, you, sir, what's the test tube? I haven't used that one. Okay, hands up for acid. Hands up for alkaline. Hands up for neutral. Okay. Hands up, you've made it adults if you think at all. So you haven't put your hands up for anything, have you? That's right, yeah. There we go. Let's take our colour check. What colour's it gone? What colour over here? Red, okay then. Is it an acid? Is it a weak acid? Is it a strong acid? This, I know for a fact, is hydrochloric acid. And hydrochloric acid is the acid that's in your stomachs that breaks down your food. Your stomach has a special lining of mucus to stop the acid burning through. So I'm going to put that over here. Let's go over to, tell you what, on the side, let's go to this side. Over the corner. People in the corner, don't do it again, mate. Point to a test tube. That one, okay. The cloudy one, okay. Hands up for acid. Hands up for alkaline. Hands up for neutral. Hands up for chocolate. Let's find out what it is.
Chocolate.
What colour is that gone? What colour over here? So it's gone the colour purple, that's our observation. Let me explain the observation. This, wait here, is it an acid? Is it neutral? Is it an alkaline? Weak alkaline? Strong alkaline? This is drain cleaner. So adults, seriously, if you're using drain cleaner at home, please put some gloves on. It is really nasty stuff. You don't want to get it in your fingers. So if there's one test tube, I might as well pick it. So hands up for acid, hands up for alkaline, hands up for neutral, hands up for England winning tomorrow. Okay, hands up for Spain. Okay, yeah. Let's find out. Now this has gone, well, I would say, a bronzy green. So, green, 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 green. So this could be, I think, let me compare the two. This one's slightly more bluey, I don't know if you can see that. I'll put it over there, so I'm going to go as far as to see it. A bit more bluey over here. That one bluey? That one bluey? So this could be a very weak alkaline. Blood can be a very weak alkaline, but I'm not quite sure what that is, but this is on water. So now we've got all through. I'm actually doing this for a very serious reason. Let's show you what that is. Here is some water in a bathing cylinder. Children, why is water important?
Hydration.
You keep you hydrated. Anything else? You can use it for shower to clean yourself, yes. Well, water is important because you are all made up of water. 70% of you is water. Our bodies are made of 70% water. Well, not just us, plants and animals as well. They need the water to be the right pH. Some animals and plants can live in acidic conditions. Some animals and plants can live in alkaline conditions. But many live in neutral water. Now, children, to show us neutral water, let's put my indicator in. So here goes the universal indicator. This is a mixture of chemicals. Complicated mixture of chemicals, as you say. Goes in, well, that's called the universal indicator, and it's called that lovely bronzy green. Now, by the way, in our world around us, we have lots of beautiful things. Many things us human beings make, and they're made mainly in factories. But as a consequence of making all these things, in order to make them, they also produce something called carbon dioxide. Now, carbon dioxide is generally a gas. Put your hands in front of your face and breathe out. That's carbon dioxide coming out of your mouth as you breathe out. There's carbon and oxygen. One atom of carbon and two atoms of oxygen. And atoms are the smallest particle of an element you can generally have. However, factories are producing way more much carbon dioxide than we bring out. It's going up into the atmosphere and reacting with the atmosphere, blanketing the earth and stopping the heat of the day escaping. It may be sort of warm okay in a moment, but later on in the year it may get very, very hot. And this is due to the hot all that hot energy is sort of being trapped by the carbon dioxide. But there's more than just that. And to show you what it does, I'm going to bring out something cold. Now, what do you have at home that's really cold in a rectangular cabinet thing that's cold? Ice, yes. So, ice, I'll get some ice out. Now, look at this. Ice, yes. Lovely ice. What is ice made out of, children? You should know this, I think. Yes. Water. We get water down to 0 degrees Celsius, you get water ice. Now look at me. Children, look at me. Look at Carlos. Do not look at your adults. Do your adults go to the fridge to get an ice cube out dressed like this? If they do, I want to know what's in that fridge, adults, because I don't think you should have to do this to dress in gloves and goggles. On my spoon is not ice. On my spoon is dry ice. Dry ice is made out of the same stuff I got you to breathe out just a few seconds ago. You breathe out gaseous carbon dioxide. This is solid carbon dioxide, and to be solid, it's got to be at minus 78.5 degrees Celsius. So super, super cold. That's super cold. So I'm going to add it to my measuring cylinder. Now this can be quite stylish, so children, don't fall backwards if you're on the benches. Here we go, ready on the count of 3. Not too much. So just to show you what it can do, count to 3. 1, 2, 3. Whoa. Now, the dry ice is being heated up by the water back into the gas. That gas is still cold, but it's going from solid to gas, that dry ice. So we call that sublimation. Everyone say sublimation. However, as that gas is still cold, that's been made from the dry ice, water bits there hit it, and they lose their heat energy. And the water bits clump together, become water mist droplets. We call that condensation. Say condensation. Like condensation experiments, at the back where I'm pointing are some more condensation experiments we used to do. But all carbon dioxide goes up in the atmosphere and reacts with the atmosphere. Now, has anyone noticed anything other than the mist coming out of my measuring cylinder? Anything else? Well done. Give them a round of applause. You were going to say that as well, weren't you? Yes, it changed colour. So, it was green, now it's sort of yellowy orange colour. So, is that an alkali? Is it neutral? Is it an acid? Yes. This is carbolic acid, a weak acid, but it's still an acid. To show you how strong this effect is, I'll put a bit more dry ice. And I'm going to pour in only the gas into my neutral water. I've just poured in the gas. Has there been a colour change? Have there been a colour change? Not really though. Colour change? No? Yes. Well, the acid, the carbon dioxide reacts with the upper atmosphere and comes down as acid rain. So the big acid rain is shaken up. Has there been a colour change now? Colour change? Just a little more to be sure. Yep, definitely a colour change. So, is that an alkali? Is it neutral? Is it an acid? Yes. So, again, this is acid. Any animals or plants that live in this water would have died out if they needed the water to be neutral. And that's why I'm weak alkali. Let me just pour it in again the gas. I'm not pouring the liquid, just the gas. So, again, has there been a colour change? Has there been a colour change? Let me use this hand, a different hand, to be the acid rain as I shake it up. Has there been a colour change now? Colour change? So, is it an alkali? No, so is it neutral? Is it an acid? Yes. Again, we've got carbolic acid. So, children, we are polluting our world too much with carbon dioxide. This may still be happening when you become adults, and you will have to take some very serious decisions to see if we continue to pollute our world with carbon dioxide or we do something about it. If we don't, lots of animals and plants will die out and we will never, ever see them again. By learning science, hopefully you'll take the right decisions. But that is a bit of a gloomy note, and I don't want to end on a gloomy note, so I'm going to put it away and do something more fun. Now, I am going to bring out a box. Are you impressed?
Sorry.
Okay. Oh, yeah, another box. Are you impressed?
Don't get boxed in.
Well, I'll tell you what.
That can't do anything.
I'll tell you why I supported in science. If we were back 700 years ago, when people knew less science, some people may think that I, Carlos, am a wizard trained in the dark arts of magic. Yes, I'm a wizard. Do you believe me?
No.
No. Fine, I can prove my magic to you then. So to do that, I'll take a candle, and I'll put some dry ice into my box. So this one is solid carbon dioxide at minus 78.5 degrees Celsius, and I light my candle. This candle does not light, so it's going to be fired. In fact, it is going to be fired. I'm putting another candle out. Wait there. No, I don't like the candle. Let's get another candle out. Aha! Yes. Now if I'm a wizard, I'm going to put that candle out without touching it. To do that, I'm going to bring out this. Is there anything in the beaker? Anything in the beaker? No. Anything in the beaker?
No.
Anything in the beaker? No. This is a magical beaker. I will attempt to put out the fire by bringing the spirits of the box into the wonderland. Please don't try this at home. This is incredibly dangerous. Summon the spirits. I'll say the magic word. Spirit of the box, I command you, put out the flame.
Wow.
Now I know what you're thinking. Carlos, you just waved the beaker over and it went out quickly.
You just connected them with carbon dioxide.
So, is the flame going out? Flame going out? Audience, is the flame going out?
No.
What were you saying?
It was the carbon dioxide.
Well, the carbon dioxide is a solid. Look at it, see there? It's a gas. You're saying the gas in here is putting out the flame. What's your name? Give him a round of applause, he's right.
Yeah.
You see, I don't know any magic. This is not magic, this is science. So, how are you saying the dry ice is sublimated way into a gas, and that gas is heavier than air. So I can scoop it up and pour it like liquid. And the flame goes out. So, this is why it's important to learn science to know how our world works. But we're not 700 years ago, we're here today in our modern world. So I'm going to put this away, but one of the uses of this science is in some types of fire extinguishers, they're loaded with dry ice instead of water or foam. So there you are. So let me show you some more. To do that, I'm going to bring out a very dangerous material, children. This dangerous material is bubble mix. So, I can't use a bubble wand in the show, but the director said if you've got coronavirus, you put a bubble with coronavirus, will drift over your children and pop, and you'll all get coronavirus. So, would you like to see a bubble?
Yes.
Would you like to see a bubble?
Yes.
Maybe I'm asking wrong people. Adults, would you like to see a bubble?
Yes, 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 yes. Pop the
You're a hard audience, aren't you? Well, you know what? I came prepared for such an audience here. I have the bubble gum. The question is, do you feel lucky? Yes? Let's find out. Bubble, 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 bubble.
Everybody try and pop the bubble.
Touch your
Whatever
bubble.
team you're supporting, if it doesn't win tomorrow, please make some bubble because it makes people happy. All the smiles on your face. Isn't that man over there? He's smiling, isn't it? They can't get enough bubbles. Now look, children, look at the bubble in the box. What is the bubble floating on? Who's got the answer? I hear you all children, carbon dioxide. So now you know, you can see where that gas is holding up my bubble that's been made from the dry ice. So let's do something good to end the show. I'm going to bring out some water, pour in all my dry ice, some condensation going, right? And over 300 years ago, a very famous scientist called Sir Isaac Newton wanted to work out what the white lights are made out of. He used a triangular piece of glass called a prism. He can do this later in the light table. I'm going to use a bubble, so let's find out. Whoa. Woo. Now, now, where you are, you can see this, children. You others may have to bend down. Can you see coloured rings forming? Can you see greens? Can you see pinks? If you look long enough, you get yellows and purples as well. Why do you get the colours? Well, the liquid of the bubble isn't a solid thing, like a brick wall. It's draining to the bottom all the time. So the bubble's draining off liquid, so thin at the top, thick at the bottom, and different coloured light energies are being trapped at different thicknesses of the bottom wall.
Hello, Wonderlab! Starting right now in this show space at the back of the gallery is the Rocket Show. Come and join our fantastic explainer Pedro to find out all about how rockets get up into space and safely back down with a few explosive experiments. Please note that this show will contain some loud noises which may not be suitable for all of our visitors. That is the Rocket Show starting right now in the show space at the back of Wonderland.
So, during the show, I'm going to pose this question to you. And we've got different liquids draining down. We're getting different colours. Why? Because the different thicknesses of liquid are trapping different coloured light energies. That's why we're getting the colours. So we prove that white light is made of colours. Truly. But during the show, I'm going to make a pop ball came in 3, 2, 1. Wow. Is that science meeting art or art meeting science? So with that, I'll continue with the chemistry bar demonstration. I hope you enjoyed it, had a lot of fun, and thanks for watching.
Thank you. Bye-bye.
And if you want to catch the Rocket Show, make your way to the show space now.
Good work. Thank you.
Thank you so much.